Hi, in this segment on my series in carbohydrates, I'm going to do a little bit of review on monosaccharides, polysaccharides, and disaccharides. I didn't really put that in the right order. And then focus on monosaccharides. So just a reminder that carbohydrates are commonly called sugars and starches. We are familiar with them in our diets. They are polyhydroxy, referencing all of these hydroxy groups, and they are aldehydes or ketones. So, or they can be hydrolyzed into smaller parts, which are aldehydes or ketones. And these are some monosaccharides here, and you'll notice that these are two straight chain monosaccharides, glucose and fructose, and they can form in cyclical structures. Glucose is a six-membered ring and fructose is a five-membered ring, but the glucose has the aldehyde group here on this carbon, and the ketone has the carbonyl group here, and this is always on the number 2 carbon. So that is the way that we can recognize the difference between a ketone and an aldehyde. This is referenced as an aldose, and this is a ketose. So disaccharides contain two monosaccharides joined together in a, this is called a glycosidic bond or a glycosidic linkage. I'm just going to write that word again, glycosidic linkage or glycosidic bond. And polysaccharides contain many units joined together. And they sometimes are linked to each other in different ways. Sometimes glucose units, these are typically glucose units. Sometimes you can have a glucose called alpha glucose, and sometimes you can have beta glucose, which is a conversation for a later time. I like to introduce that terminology though from time to time so that when we hear it again, it won't be the first time that you have heard it. So specifically talking about monosaccharides today. We have the simplest aldose, which is glycerolaldehyde, 3 carbons with an aldehyde group on the end. And the simplest ketose is a ketone, is dihydroxyacetone. So you will not need to memorize these names. These are just the simplest ones. So we are going to focus on classification. Oh, characteristics next. Monosaccharides are sweet tasting. Their relative sweetness varies greatly. They're very different in terms of the degree of sweetness. They're very polar compounds because of all of those hydroxy groups. And because there are so many polar functional groups that they can undergo extensive hydrogen bonding, which makes monosaccharides in particular very water soluble. They are small, ample hydrogen bonding with all those OH groups. And we are going to focus on how we can classify monosaccharides, and we can base it on whether they're an aldose or a ketose, how many carbons there are, whether it's a left-handed molecule or a right-handed molecule. And then another way that monosaccharides get classified is through optical activity, and what they do is they actually run a light through a sample, and the light kind of bends a certain way, and depending on which way it bends, it'll either bend to the right or bend to the left, and that's just it's beyond the scope of what we talk about in here. So looking at the classification of aldose versus ketose, monosaccharides generally only have between 3 and 6 carbons, and the aldehyde is always the number 1 carbon, and the ketone, the carbonyl group on a ketone, is always at the carbon number 2. All right, so the carbonyl on an aldehyde is at the carbon number 1. So where that aldehyde is carbon number 1, and where the carbonyl group is on a ketone is carbon number 2. So if it is an aldehyde, we call it an aldose, and if it's a ketone, we call it a ketose. Something that will come to play later is that aldoses that are monosaccharides will oxidize to form carboxylic acids, and we can use a series of tests that signify that. And just as a little introduction, we have the Tollens test, which was the silver mirror. When the aldehyde was put in oxidizing conditions, it turned silver. And then there was the Benedicts and the Phthalines, which both were a blue solution, and they turned a brick red color. So the fact that carbohydrates are either aldehydes or ketones plays a role in us being able to utilize these tests for confirmation of their existence, whether we have an aldose or not. So another way we can classify carbons is based on the number of carbons in the chain, and if it has 3 carbons, we say that it is a triose, and 4 carbons is called a tetrose, pentose is for 5, and a hexose is for 6. Now, what we do is we combine the word aldose and ketose with this numbering scheme, and that makes a glyceraldehyde be an aldotriose. Aldo for the aldehyde, tri for 3 carbons. And this dihydroxyacetone is a ketotriose. So it is a ketone. There are 3 carbons. 1, 2, 3. So it is a ketotriose. So let's practice with this a little bit. Let's classify each of these as either an aldo something. So is it going to start with aldo or is it going to start with keto? And then this part is going to be the number of carbons, that prefix, and then it's going to end in ose. So pause this right now and see if you can try your hand at this. Okay, I hope that you really paused it and you really tried it. And let's go through this. The answers, this is an aldehyde. We see that CHO at the top, and this is also an aldehyde. And here we have a ketone. We have 1, 2, 3, 4, 5, 6 carbons, which makes this an aldohexose. 1, 2, 3, 4, which makes this a ketotetrose. And 1, 2, 3, 4, 5, which makes that an aldopentose. If we were to test whether or not these could be oxidized, aldehydes can be oxidized to form carboxylic acids, and they would test positive with that Tollens test or with the Benedict's test. So another classification scheme that exists is chirality. Is the molecule left-handed or is it right-handed? Now, if when carbohydrates are left-handed, there is a prefix like levulose. The left-handed glucose is called levulose. The right-handed glucose is called dextrose. And you are not going to need to know how to identify a left-handed from a right-handed. It actually all has to do on what the hydroxy, which side this OH group is on, which it doesn't really matter, but just need to know that there are left-handed and right-handed molecules. Now, the sugars that occur in natural systems are right-handed, the D variations. So all naturally occurring sugars are D right-handed sugars. And dextrose, if you have worked in the medical field before, or if you ultimately end up there, dextrose is the name of the sugar solution that they put into IV bags, and it is regular right-handed glucose. So here are some common monosaccharides that we're going to talk about in more detail. You should know the common names of these, that the right-handed glucose is a blood sugar, but it's also called dextrose. I should have included that here. Here I'm going to blood sugar slash dextrose. Galactose is a monosaccharide, and it is called milk sugar. And fructose is also a monosaccharide, and it's called fruit sugar. So these two are aldehydes, and the fructose is a ketone. Now, the one thing about each and every one of these is they have the same exact chemical composition. They are all C6H12O6. They're all built just a little bit differently. Here, you can see that everything is the same except pretty much this right here. These OH are swapped. That's the only difference between galactose and glucose. So glucose is also known as blood sugar. It's also known as grape sugar, and it is the most abundant monosaccharide. Our polysaccharides are made of glucose. It is carried by the bloodstream to all body parts, and it is the monomer. It is that unit that gets repeated in our polysaccharides. So these are just a reminder that these monosaccharides can oscillate between a straight chain and a closed cyclical structure. And this happens to show the two types of glucose. This is called an alpha glucose. And in an alpha glucose, on this carbon right here, our OH is at the bottom. And on a beta glucose, on that same carbon right there, the OH is at the top. So they're just swapped. And what we find out is that alpha glucose is what makes up starches, and beta glucose is what makes up cellulose. So wood fibers and paper fibers and cotton fibers are all cellulose, and our starches are, you know, like cornstarch or starchy foods. You're familiar with starch. Our normal blood glucose levels, according to the NWTC PowerPoint, is between 70 and 110. However, this one that I got on the internet, which you should just believe everything that you see on the internet, says between 80 and 100, so it's a little bit tighter range. I think you're going to see a variety of numbers depending on the source. Healthy humans keep blood glucose levels in check. And there are two hormones that are released by the pancreas. We have insulin and glucagon. And if your blood sugar levels get too high, it causes insulin to be released, and that starts making your body use up that blood sugar really fast to lower the levels in your blood. If your blood sugar levels get pretty low, the glucagon is released, and it causes stored polysaccharides in your body in the form of glycogen to break down and form glucose. Now, I just included this whole series of metabolism in a few words, and it's not really that important right now because we will investigate that later, and I will have diagrams that goes through all of that. So some people with diabetes cannot regulate the maintenance of normal blood glucose levels, and we will also discuss diabetes and the role of insulin and glucagon on blood sugar maintenance in your body at a later time. Galactose is one of the components of the disaccharide lactose. You have heard of lactose. Some people are lactose intolerant. And galactose is synthesized in mammary glands of mammals to make lactose. And it's found in many glycolipids. So this is a cell membrane here. It's this bilipid layer, and that will make much more sense after we've talked about lipids. But sometimes we have these things just sticking off of the top of these lipids, which are fats, and they're called sugar residues. So galactose can often be found as the sugar unit in that are sticking out of cell membranes. Patients with galactosemia will lack an enzyme needed to metabolize this, and this is different than lactose intolerance. It's not the same thing, but if a patient lacks the enzyme to metabolize this, it can accumulate and cause liver problems and cataracts. So the one thing that I wanted to notice here is that this is one of the basic panels for a newborn screening, so that can be identified very, very quickly to see if a patient does lack that enzyme. And fructose is one of the components of the disaccharide sucrose. Here is sucrose here, my fructose portion right here, my glucose portion right there. If we hydrolyze that, we get our glucose and our fructose separately. And it is a ketohexose. So these are ringed structures, but I want to remind you that in that straight chain, there are 1, 2, 3, 4, 5, 6 carbons, and on the second one is where that carbonyl group is. Extremely sweet. It is the sweetest monosaccharide, and naturally found in honey and other natural sources. But we also generate fructose from starch through a series of enzymes, and this was discussed in the enzymes unit, how it's a very complicated process that turns starch into high fructose. So sometimes people are looking at alternatives to eating sucrose, and the idea of high fructose corn syrup has been a buzzword lately. People have linked it to poor health, and there are lots of studies that support this. Sucrose is 50% fructose. Dates are 30%. Honey is about 40%. The agave, I don't know how to say that. This is about 90% fructose. So if you're using that as a sweetener, as an alternative, and you're trying to limit your fructose intake because of the effects that it can have on the body, this might not be a good choice. And then there are other alternatives that range between 38. Stevia doesn't have any, nor does rice malt syrup, and I have not used either of those as sweeteners before. I think I may have used stevia once. It was bitter, kind of gross. But I think that it's interesting to look at this. This was a study that was done in which participants had ingested 50 grams of sugar from honey, sucrose, or high fructose corn syrup, and they looked at the level of plasma triglycerides, and at 50 grams per day, they noticed with sugar those triglycerides, which are associated with high cholesterol, very low density lipoproteins, so LDL, and within 2 weeks. And honey, the increase was within 2 weeks, and the high fructose corn syrup was also increased within 2 weeks. So there really wasn't that much of a difference between these sweeteners because they all contain fructose. So high fructose corn syrup is only about 55% fructose, sugar is 50%, and honey was here about 40%. So really not that much different from each other. So this concludes my discussion on monosaccharides. Particularly, we looked in depth at glucose and galactose and fructose, and also how to classify monosaccharides. So I hope that you learned something about that. Thanks for watching.